All right. Well, people are still joining. I guess it's not a big deal if it's online. You don't at least you don't have people walking in front of you as they try to find a seat. So let's get started. I'll be talking about one of the subjects that is very dear to my heart, which is CQRS and event sourcing. And for those who know me, they know every talk I have will include something about CQRS and event sourcing. But in this case, they will not take the main stage of the talk. I want to talk about communication, and communication not between humans, but between components in software. And the background I have with CQRS and event sourcing gave me a little bit of a different perspective to the style of communication, and it actually made me less fond of the typical HTTP and message broker centric approach that we very often still see today. So my name is Allard Buijze. I'm the CTO and founder of AxonIQ, and the reason I founded AxonIQ, I'll get to that in a little second. So many of you probably know this this diagram. It's taken from the Reactive manifesto, to be exact, from version number 2 of the Reactive manifesto, because version number 1 would have not message driven, but rather event driven in there. And I think that is one of the very good modifications that they've made. There's another document, however, that I think supersedes the Reactive manifesto, which is the Reactive principles, which you can find on principles.reactive.foundation. I can definitely recommend reading that. It's actually a pretty easy read, and there's a lot of very interesting information about building reactive applications and what it means and how to do that. So let's go back a little bit in time. As I said, I have a slightly different perspective, so I want to briefly explain where I came from and where that perspective came from and how that's different, and maybe how we can use that to improve the reactiveness of our systems going forward. So it all started, at least for me, it started when I started applying domain-driven design to projects, and in some cases it was just a good attempt. And some other cases, I took it more seriously, definitely the ones after 2008, when I followed a training about domain-driven design. But what I noticed is that it really helped, tackle the complexity, as the book title is called. But something was missing, right? Still at the for the larger scale systems that we were building at the time. It took us a long way, but it didn't solve some of the issues that I expected to have been solved. So in 2008, some new concepts emerged, if you will. Event sourcing is definitely not invented in 2008. It was invented probably thousands of years earlier, but in 2008 they were popularized by Greg Young. And I started experimenting with those concepts a little bit, because I felt that they might have addressed some of those issues I had. And those experiments were good fun. Not all of them very successful. This is not a picture of me, fortunately. But if IT were physical chemistry, then probably this would have happened a few times, because I've made some really, really stupid mistakes. But those really stupid mistakes were a very good learning experience, and they helped me get a deeper understanding of what CQRS and event sourcing could do, and definitely what they could not do. But out of those experiments, I guess I accidentally created a framework. I noticed that a lot of the code that was required to make this work and to make it usable involved a lot of plumbing, right? And I put that in a separate repository, and if you create a repository, you need a name. So, ultimately, the name Axon came out of it, and people started using that, which was great fun. But I want to fast forward to around 2014, 15-ish, when microservices became more of a hot topic. Right, there was a book by Sam Newman. I don't recall the title. Could have looked it up, I guess, and it made the concept of microservices very popular. And you see that well, this is the Google Trends graph. You can see that the interest really went to well, I guess all the way to 100%, which is, I guess, pretty high. But more importantly, or as a reaction to that, we also saw the usage of Axon increase a lot. And initially, we just thought it was an increase, but we were quickly able to correlate the increase of the number of downloads to the usage of microservices. And apparently, Axon and microservices were a good fit. And I think I can generalize that. CQRS and event sourcing and microservices are a very good match. And of course, my first reaction was, cool, right? This is really nice, because it means that there's demand for something that you've built. And by then I've spent 6 or 7 years of my life, well, not full time, but lots of evenings on building that stuff. And it's really nice when people downloaded it. But I also started asking myself, why? I mean, it's really nice that something works, but I want to understand why, so that maybe I can make it work better. And for that, we had some discussions, and we noticed that there's the non-functionals, especially, that CQRS and event sourcing allow you to tackle, the so-called illities. It seemed that CQRS and event sourcing were really good at addressing those illities, right? So applications become more complex, but still we want users to be able to use it. So there's things like scalability, okay, I had to cheat for this one, sorry, elasticity, which is more important than scalability. Very often we think about scaling out, but we don't think about scaling back in, which is equally important. Flexibility, right? We want to be able to adapt our software. We want to be able to extend it with new features. And that's easy, but extensibility while maintaining a acceptable level of complexity that allows you to maintain the software, that becomes more challenging. Okay, great. But how? So it addresses those illities, but how does it do that? What are the secret ingredients in this? Because it can't be that CQRS and event sourcing are the silver bullet. There must be something in there that is a good ingredient that helps us forward. And for those who are not familiar with CQRS, I know it's a term that appears a lot at conferences. I've seen it a couple of times today as well. But just a quick recap. The idea of CQRS is basically that you split your application into roughly 2 parts. One part is responsible for handling commands, and the other part is responsible for handling queries. And commands are effectively instructions to change the application state, whereas queries are requests for information about the application's current state. Right? And the idea is, by separating those into 2 different areas, we can build domain models, if you use DDD, or at least different components that focus on the different aspects and the different needs of that particular side of the application. So that means you can build command models that focus much more, that contain all the logic, just the logic to make modifications to an application, whereas your query model, or projections as they call, they can focus on the type of questions that your UIs and APIs have, or maybe other components may have, and they optimize just for answering those questions. And this will probably give you a lot more code, but that lot more code is a lot simpler to reason about and therefore to maintain. And you can tackle these illities in a different way. So if you have one part of an application that is very complex and needs to be deployed very often, well, it makes sense to have that as a separate component, completely separated from another part of the application that is very simple and rarely deployed. right? There's a different amount of attention that you want to put in these different components. And the same on the projection side. Maybe you have some components that have seasonal usage peaks. If you're in retail, Christmas might be one of those peaks that's coming up. So I'm pretty sure those people in those domains are bracing themselves for Black Friday. And maybe some other components are quite unstable and maybe memory aggressive. You want to be able to isolate those components so that they don't cause problems for the rest of the application. And another nice thing about this style is that you can use events the command model can publish events onto some sort of queue, and then the projections can consume those events. And it doesn't really matter if you have 1 or 200 projections. They can all just tap into that same event stream and build whatever projection they feel necessary to provide information to the outside world. And what you can also do is use event sourcing on that command model. And that's also something I want to spend a few minutes on to explain, because there's a lot of confusion of what event sourcing is as opposed to event streaming. So consider two services, in this case service A and B. A is on the left, B is on the right, and there's some form of messaging queue in the middle, right? We'll call it the event queue. If service A and service A has its own state somewhere, and it makes decisions, and it gets a request to change that state, what it can do as a result of that is publish an event, and it will place that event on the queue. Now service B, whenever it's ready, it can consume events from that same queue, and it can start from the beginning, it can start from the middle, maybe it's streaming just live events. But it can stream those events any way it likes and update whatever projections of those streams, or maybe it triggers third-party systems to do something, but it will trigger some activity of some sort. This is called event streaming, right? This has nothing to do with event sourcing. Now, when we take service A, instead of using a state store to store states, but if we have service A make decisions to change states solely by looking at the event log that effectively it published to in the past, that's when we do event sourcing. So event sourcing is something that is limited to a single service using its own past decisions, represented by events, to make new decisions. And there's some pros and cons, and I'm not going into the pros and cons in this session. But what I noticed is, while I was working on this event sourcing framework, essentially, and working on my understanding of what event sourcing is, I was attending some meetups, and I saw some presentations about event-driven microservices, right? Events were getting hot. Microservices were already hot, so if you combine them, you probably have the holy grail. And what I saw presented there was a style of event-driven that started with the rule that all communication should be through events. And that's already interesting, because when a rule says you have to apply it for everything, it usually means it doesn't work. So what they said is, well, the order service, when an order is created, it publishes an order created event. Well, that sounds quite reasonable. But it does so with the expectation of a shipping service to confirm the inventory. So the application, the order service, would then wait, maybe not actively, but it would at least wait for an inventory to be confirmed. So there was already some expectation there. And then it says, order ready for payment. Well, that does sound like an event, but if you send it with the expectation that some other service says, oh, the order is paid now, is it still an event? And then the order is ready for shipping. Shipment is created, right? So they all sound like events, but they have an underlying expectation. And the style of communication, or the style of communication that's being used here is also referred to as choreography. So every component does what it needs to do, and they know when some other component does something, they know how to respond to that, right? So there's a predefined set of rules of things to do. When this happens, when that happens, you do that, etc. So there's very much like choreography in dancing, right? You rehearse up front so you know what to do when, and you make sure that everything stays in sync. You can't go your own way completely. But this is just one of several communication styles, and I think the one that is very often combined with choreography is orchestration. Now, orchestration is somewhat different. Still, every component knows exactly what to do, yet there is another component that sort of directs what a component should do when, right? And that's the conductor of an orchestra. The conductor basically says who should do what when and how, and there's a certain margin of influence that these conductors have. In fact, there's a very big margin of influence they have. But we all know that in this case, ballet and classical music are best to be combined. Right? The best results are achieved when combining choreography and orchestration in the right amounts. And that's great. We're not on a dance floor. We're not doing ballet. We're in software engineering. So how do we do that in software engineering? And I think the style of communication and the ingredients that we can use, they're already in this architectural diagram. You can see the communication that we use are commands, their queries, and their events. And all of these messages, they're sent with a certain expectation. And if anything in software engineering helps make things more clear, is by making them explicit. Making things explicit is sometimes extremely hard because it sometimes requires you to come up with a name, and that is still seen as one of the hardest things in software engineering. But making them explicit is really worth it. And in our case, what we want to be explicit about are the expectations with which you send a certain message. Now, I've already been talking about events, and events are generally or it seems that the consensus about what events are, and that's the way I like to use them, is a notification that something relevant has happened. So something has happened. It's past tense. It's in the past. It happened. There's nothing we can do about it, and you just notify other components that it happened. You're not expecting any response or any direct activity back, right? There's no explicit expectations. It's just information. For your information, this happened. But sometimes we want another component to actually do something. We expect a certain result to come out of a message, not so much a result coming back, but more of a side effect, right? We expect the state of the system to change when a certain message is processed. And those are typically referred to as commands. And in some other cases, we send a message because we have a need for information. There's some information we don't have, and we need that to make a particular decision. But because we don't have the information, it has to come from elsewhere. And that is what we can use queries for. And the interesting thing is that all of these messages follow different routing patterns. There's different optimal patterns in which we route these messages to the right components. And I'll get to that in more detail. But it's very important to not conflate the concepts of events and messages, right? Events are an example of messages, but not all messages are events. Right? There's other types of messages, and if we are more explicit about what kind of side effects or action we expect from those messages, it will help simplify our architecture. So let's have a quick look at these different routing patterns. So imagine there's a component that knows something happened, probably because it did that thing that happened itself, right? It triggered some action somewhere. Well, basically, it can just use pub sub, right? An event is very safe to publish to any component that is interested, in theory. In practice, there's a few caveats to keep in mind. There's things like competing consumers. Maybe two of these components act on these events in the same way, and they just are two components for the purpose of load balancing. In that case, we probably want to consume these events, or to have the competing consumers pattern And in some other cases, they need to consume it parallel to another component because it does something else with those events. So those are things to still keep in mind. And make sure that there is a decent amount of consumer balancing, so that if you have 2 or 3 or 4 components that compete for messages, that you don't have one that's extremely busy and the other ones are just waiting and seeing all the messages flow to the component that's really busy. And there's also sometimes requirements on sequential processing. Right? If one event happens first and the next one happens after, and that is the way we need to process them in a certain projection, we have to be careful with parallel or at least competing consumers, that the one event is processed after the other event. And then there's command routing. Now, commands are not routed using pub/sub mechanisms typically. For a command, you expect a certain component to act on it. So there's a side effect that's being created, generally an event that gets published onto an event stream. But generally, a single component will need to process that command. And as a sender, you don't really care much about which component it is, as long as there's one, and you probably want to get some acknowledgement or failure back if for some reason the command could not be executed on. But generally, there's not much of a response, right? It's just a simple acknowledgement or failure report is enough. And one thing to keep in mind is that to make sure that several commands that need to act on the same domain level concept in domain-driven design called an aggregate, if multiple commands are triggering that same, let's say, piece of state of an application, you can use consistent hashing to route that command to the same destination. It's a very efficient algorithm, and it gives us the ability to make sure that a single component receives all of the commands for a single entity, and thus allowing us to locally optimize processing for that entity. And then up to the queries. Now, queries are completely different, I would say. Although there's different styles, and the point-to-point query is somewhat similar to a command. You can effectively route it to any component, right? If you're asking a question about the current state of an application and you have 3 components that can answer that state, then any of these 3 components will do, and they will answer it. So we can use round robin, or we can do performance-based routing or whatsoever. But in some cases, you don't have a single authoritative answer. In some cases, there are different components that have a certain opinion on the state. And in that case, you want to publish the question to multiple components and gather the answers, and probably do some MapReduce function or reduction function on the receiving end to combine the multiple answers into a single response. And the nice thing is that if a certain component fails, or if we add more components to our infrastructure, we don't need to change anything else. We just have more responses coming in for any component that sends such a query. We do have to keep in mind that since we don't know how many responses we're going to get, there should always be a deadline for responses. So how long are you able to wait for a response in case you get less than expected? And the last one is an interesting one. It's what we call the subscription query. It's essentially a query that keeps you up to date as the response to your answer changes. And for that, we basically have a point-to-point query. At first, it is routed to a single component, but then any component that sees some changes to that state can send updates. And in that case, the client first receives the current state and then receives all updates to that state as it happens. And this is a really nice feature or a nice pattern if you like to build real-time UIs. And in my opinion, one of the ways to prevent all sorts of problems with eventual consistency, especially on screens, is to make information more, well, flowing, if you will. And as the information updates, why not update the end user's information right away? And what this gives us is pretty interesting. It gives us a concept that's called location transparency. Also a concept that is described in the Reactive principles document. And the idea of location transparency is that a component is not able nor makes any is not aware or makes any assumptions of the components it interacts with. And using these messages and explicit styles of messages helps, because all you do is send a message on a bus. You don't, as a component, you don't need to know where that message needs to go. But even better, the component doesn't even need to know which other component it interacts with. It can just send a query and rely on the messaging mechanism that is underneath that query bus, for example, to route the query to a component that has indicated is able to interact with it. Now, this is an interesting concept when we build microservices, because we know that if we take the style of software development that gives us a big ball of mud, right, an unmaintainable software, and we increase the number of deployment units, what we get is a distributed monolith or a distributed big ball of mud. So instead, we need to focus on the modularity and then increase the number of deployment units so that we can get to microservices. Where we want to be is in the top right. Unfortunately, reality always brings us down and always tries to things happen in projects that force us to take shortcuts. We make choices that we regret later on, et cetera, et cetera. And as we have more deployment units, it becomes harder to maintain, and we need more discipline to maintain the software at the high standards of modularity. And this is where I feel that the messaging can help. And we know different styles. We see different styles of products. The ESB, which is very knowledgeable and aware of payloads. They know exactly what kind of messages they transport. And they add a lot of complexity, or they are able to add a lot of complexity. And what we see as a counter movement is a lot of messaging systems that just do pub sub, right? Just place a message on it and any component can read it anytime. They're completely payload unaware, but they add a lot of complexity to the applications themselves, because now they need to make sure that, well, if you use pub sub for a command, how do you make sure that only one component will handle it? That's a tricky thing to do. So what we believe in is that we need to move slightly to the right, where we have stereotype-based routing, and more important, it's application-driven. So the applications tell a messaging mechanism to what kind of messages they can handle and how they should be routed, not how they should be routed, but what they can handle, so that the messaging system knows, okay, this is a command and it has that name. I need to route it consistently to a particular destination. And that allows us to take, well, a little detour, I would say, in building microservices, where we start with a monolith and we gradually evolve that monolith into microservices. And that's all good and nice, but that adds a lot of complexity, right? This is doing that right is very complex, and that's something I've learned in the past 11 years experimenting with CQRS and event sourcing. And the thing is, the solution is actually not that far away, is to use the right tools. And it doesn't really matter which tools you use, whether it's Kafka, RabbitMQ, ActiveMQ, or the tools that we have been creating specifically for this purpose. But we have to pick the right tools for the job. Think about these messaging patterns. Think about how you want to make it explicit, and then find the tools that help you implement those patterns. But more important than tools, what we need is discipline. And this is a brief picture from the Karate Kid, where Mr. Miyagi lets the little boy wax his car, wax on, wax off, to teach him karate. And it's just essentially a training to get discipline into the kid. In our industry, discipline has different shapes than waxing on, waxing off. We can use concepts like domain-driven design, event storming, and event modeling. Very interesting. If you want to look into those, I can definitely recommend that. So in closing, microservices are a journey. They start with a monolith, And we need to consider commands and queries as much as we consider events. So it's not really event-driven, it's message-driven that we should be aiming for. We need to pick the right tools, but more importantly, we need to wax on, wax off. And I apologize for the subliminal messaging here, but if you have any questions, I think we have a few minutes left before I have to move you to the other room. Here's some links with more information, and let's see if we have a few questions. Are you an orchestral musician? I wish. I used to play some piano in the past, but I had to give up. So projections, are these materialized database views? Good question. Now, any question related to domain-driven design has to be answered with "it depends," and so does this question. It depends, but very often they are. But it depends on the entities. And I've seen some systems where they are not materialized database views, but rather in-memory projections that are kept in memory. And as soon as the application shut down and restarts, it will replay the entire history in memory just to be able to serve the information quickly. So it's all a balance between the, I guess, the entities that are important to you. But the most pragmatic approach, or the commonly seen one, is that yes, projections are materialized database views. Would you consider the actor pattern to be a good choice to cover many of the concerns you listed? Well, personally, I am not a big fan of the actor pattern. Although maybe if we have a chat about it, we do discover that I am a fan. Maybe I'm just not a fan of how it's commonly implemented. But I think they do approach. Obviously, they do approach some of these challenges. And if whatever framework or infrastructure allows you to be explicit about the types of messages that you send, then I'm pretty sure any architectural style will work. Can I use Axon Framework and Kafka as the event backbone instead of Axon Server? Short answer is yes, you can, as long as you're not using event sourcing. Because let me say it just clearly, Kafka and event sourcing is not a good idea. Kafka and event streaming works fine. But yeah, if you want to use Kafka as an event backbone, then yeah, that's one of the things it was created for. Right. One more question. Doesn't the command model introduce a single point of failure in the architecture? Doesn't it induce a performance overhead as well, where commands need to go one by one to preserve consistency? That's a good question, and the answer is no. It is not a single point of failure, and it is also not you don't have to have commands one by one. Now, there's a very important concept in domain-driven design called the aggregate. And yes, for a single aggregate, you have this strong consistency boundary. That's the definition of what an aggregate is. So for one aggregate, yes, you'll have commands come in one by one. But across aggregates, it's fine to have eventual consistency, and there's no problem to handle commands concurrently. So in fact, they are very scalable. They do require you to have a little bit of upfront design. I'm afraid that's as much time as I could take for this talk. I'm going to have to shut this session down. If you have any questions that you really would like to discuss, either face-to-face or through chat, I am going to the exhibitor booth of AxonIQ right now, and maybe I'll see you there. And otherwise, enjoy the next session. All right. Thank you. Bye.